In the study of trigonometry, it is very convenient to be able to recall quickly what the 6 trigonometric function values are for our special angles related to our special triangles. So in other words, angles that are multiples of pi over 6, pi over 4, and pi over 3. When we have a right triangle with an angle of pi over 4, then we know that the other angle must be pi over 4. And we remember that the side ratios are the square root of 2, the square root of 2, and 2. When we have a right triangle with an interior angle of pi over 3, we know that the remaining angle must be pi over 6, so that they sum to pi, or 180 degrees. The side ratios for this triangle are 1, 2, and the square root of 3. So now, if we were to draw angles as we go around the unit circle in a counterclockwise rotation, and start with the angle pi over 6, and then pi over 4, and then pi over 3, we see that we will start this progression that we have listed in the top of this table. I've started with the angle 0, and then pi over 6, and then pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. So this is just this progression that I've started here all the way around until we make our way through the second quadrant. So what we want to do is identify the 6 trigonometric functions for those angles. So let's start with 0. Well, the angle 0, which means that the terminal side and the initial side of the angle are the same when in standard position, we wind up with the terminal side intersecting the unit circle at this point, which would be 1, 0. Now we remember that the sine function can be expressed as the sine of theta equal to opposite over hypotenuse, or when we are looking on a graph, y over r. So since this is a unit circle, r is equal to 1, and at the point where the terminal side of the angle 0 and the unit circle intersect, the y-coordinate is 0. So therefore, the sine of 0 is 0 over 1, or in other words, 0. The cosine would be the x-coordinate, because the cosine of theta, which we describe as adjacent over hypotenuse, or in other words, x over r, the x-coordinate of the point where the terminal side intersects the unit circle would be 1, and the radius is 1, so therefore the cosine of 0 is 1 over 1, or 1. We can find the tangent value ratio as opposite over adjacent, or y over x. So in this case, the y-coordinate is 0, the x-coordinate is 1, so the tangent is 0. Now the cotangent is the inverse of the tangent, the inverse of that ratio. Well, the tangent is 0 over 1, so the cotangent is 1 over 0, so in other words, that is undefined. The secant we find by inverting the cosine, which in this case is 1, and when we invert 1 over 1, we still get 1 over 1, so the secant is 1. The cosecant is found by inverting the sine. The sine is 0, so 0 over 1 inverted would be 1 over 0, or again, we have an undefined value. Now we'll move around to pi over 6. We can look at our special triangle where pi over 6 is one of the included angles. The sine we can find as opposite over hypotenuse, so in this case, we would have 1/2. The cosine is the adjacent over the hypotenuse, so the square root of 3 over 2. The tangent is the opposite over the adjacent, which would be 1 over the square root of 3, and when we rationalize that denominator, we'd have the square root of 3 over 3. The cotangent is the adjacent over the opposite, so the square root of 3 over 1, so the square root of 3. The secant is the inverse of the cosine, or we can say hypotenuse over adjacent. Either way, 2 divided by the square root of 3, which we would then rationalize the denominator and end up with 2 times the square root of 3 over 3. And the cosecant is the hypotenuse over the opposite, which is 2 over 1, or we could find the inverse of the sine. Either way, we get 2. Now moving on to the angle pi over 4. So at pi over 4, the sine function, when we look at either of these angles, pi over 4 angles, the opposite is the square root of 2. So the sine opposite over hypotenuse would be the square root of 2 over 2. The cosine would also be the square root of 2 over 2. The tangent, which is opposite over adjacent, or square root of 2 over square root of 2, is 1. The cotangent, which is the adjacent over the opposite, or the tangent inverted, would also be 1. The secant, which would be the hypotenuse divided by the adjacent, 2 over the square root of 2, would simplify to the square root of 2. And the same with the cosecant. Now looking at the triangle where pi over 3 is an included angle, we can find the sine function value to be the square root of 3 over 2. Opposite over hypotenuse. The cosine would be 1/2, adjacent over hypotenuse. The tangent would be the square root of 3 over 1, or the square root of 3, opposite over adjacent. The cotangent would be the adjacent divided by the opposite, 1 over the square root of 3, which we would rationalize to get square root of 3 over 3. The secant we could find as the hypotenuse divided by the adjacent, which would be 2 over 1, or 2. The cosecant would be the hypotenuse divided by the opposite. So 2 divided by the square root of 3, or once we rationalize the denominator, 2 times the square root of 3 divided by 3. Pi over 2 is the 90-degree angle. And when we are in standard position like this, the coordinates of the dot where the terminal side would intersect the unit circle would be 0, 1. So the sine function value, which would be y divided by r, y is 1, r is 1, would be 1. The cosine value, x over r, 0 over 1, would be 0. The tangent function value would be y over x, which would be 1 divided by 0, or undefined. The cotangent would be x over y, 0 over 1, so 0. The secant would be r over x, 1 over 0, which would be undefined. The cosecant would be r over y, 1 over 1, or 1. Now we are moving into the second quadrant. And something that we have to keep in mind in the second quadrant is that the x-coordinates of the points in the second quadrant are negative and the y-coordinates are positive. So our first angle that we would find here in this progression would be 2 pi over 3. The next would be 3 pi over 4. And the next would be 5 pi over 6. And then we would reach pi. Now what we have to do when we get into the second quadrant is think about the reference angles that we encounter. And if we were to take each of these terminal sides, let's start with 2 pi over 3 and drop a vertical to the x-axis, we form a triangle. And looking at this triangle, we can see that the angle that the terminal side makes with the x-axis, and by that I mean the acute angle, so this one here, would be pi over 3, which makes the one at the top pi over 6, which is just the triangle that we have drawn here. But the thing we have to think about that's different here is that in the second quadrant, the x-coordinates are negative and the y-coordinates are positive. So when we look at our trigonometric function ratios, we have to consider the positive and negative orientation of x, y, and r. R will always be positive since it's the radius of the circle. So now when we go through our trigonometric function values for the angle 2 pi over 3, we have to consider that anyone where we have y over r, or r over y, we would have a positive result. But anyone like the cosine where we have x over r, or the secant where we have r over x, it would be negative. Also for tangent and cotangent. So for the sine of 2 pi over 3, we think about our reference angle, which would be pi over 3. That's the acute angle that the terminal side makes with the x-axis. So we'll use our special triangle with the angle pi over 3 and determine what these trig function ratios will be. So for 2 pi over 3, the sine function value will be the square root of 3 over 2. Opposite over hypotenuse. The cosine value will then be negative 1 over 2. The cosine is negative in the second quadrant because its ratio is x over r, where x is negative in the second quadrant and r is positive. The tangent function value for 2 pi over 3 will be negative square root of 3. Remember, the tangent is opposite over adjacent, so square root of 3 over 1, but in the second quadrant, x is negative, y is positive. So we have a ratio with one positive, one negative, so it ends up being negative. The cotangent would also be negative since it will be x over y. And when we rationalize the denominator, we wind up with negative square root of 3 over 3. The secant is the inverse of the cosine, so we would wind up with negative 2. And the cosecant is the inverse of the sine, so we would have 2 times the square root of 3 over 3. 3 pi over 4, if we do the same, drop a vertical to the x-axis. Now we wind up with a triangle that has pi over 4 and pi over 4 as its internal angles. So again, the sine cosine, tangent, cotangent, secant, and cosecant function values will be the same as those for pi over 4, except that the cosine, tangent, cotangent, and secant will all be negative. So we will have the square root of 2 over 2, negative square root of 2 over 2, negative 1, negative 1, negative the square root of 2, and positive the square root of 2. Now, moving on to 5 pi over 6. Drop a vertical to the x-axis. And we again wind up with a triangle that has internal angles of pi over 6 and pi over 3. So, our trig function values will be the same as those for pi over 6, since the reference angle for 5 pi over 6 is pi over 6, except that the cosine, tangent, cotangent, and secant will be negative. So we'll have 1/2 negative the square root of 3 over 2, negative the square root of 3 over 3, negative the square root of 3, negative 2 times the square root of 3 over 3, and 2. Now, for the angle pi, the terminal side intersects the unit circle at the point -1, 0. So the sine function value is again 0. Y over r, 0 over 1. The cosine function value now is -1. -1 divided by 1, x over r. The tangent would be y over x, 0 over -1, or 0. The cotangent, x over y, so -1 over 0, which would be undefined. The secant is going to be the inverse of the cosine ratio, so still -1. The cosecant is the inverse of the sine function ratio, so undefined again. Now I would encourage you to continue this exercise by moving all the rest of the way around the unit circle. Practice determining what these angles are as you go around in this exact same progression. Practice finding what the reference angles are and finding what the trig function values will be. So complete this table for yourself all the way around to 2 pi.